From the New York Times, I'm Katrin Benholt. This is The Daily. Many of the effects of climate change are already with us. Heat waves, droughts, wildfires, flooding. But some of the most alarming consequences are hiding beneath the surface of the ocean. Today, my colleagues David Gelles and Raymond Zhong on just how close we might be to a tipping point. It's Tuesday, May 7th. David, you've been writing about different aspects of climate change for years, and are definitely no stranger to distressing news about a warming planet. But something about ocean temperatures seems particularly distressing. What's going on?
Starting last year, scientists started noting something alarming happening in oceans all around the world. It was warm in the oceans, but it started to get really hot in ways that they had never seen before. And for the last year plus, I've been checking in with scientists, and they are increasingly concerned, perplexed even, with what they're seeing.
And when you say oceans are getting hotter, can you just give me a sense of how much the oceans are warming and how fast?
Well, if you look at a chart that shows, say, the last 2 or 3 decades of average sea surface temperatures, you'll see a gradual warming trend. But starting last March, we didn't see another gradual increase. We saw this big jump. And from March of 2023 on, it stayed hot, and it's just getting hotter. And we began 2024 at this much higher level than we've ever seen before, and we're still there. And in many parts of the world, the temperatures are still going up as we head into summer. And that has scientists really concerned.
And you said earlier that none of the scientists that you've been checking in with and none of these very sophisticated climate models that they're operating with can explain this big jump. And I guess I have to ask at this point, why are these scientists so surprised? I mean, we've seen record-breaking heat waves for the past several years. It seems like every single year is hotter than the last. Why is it any surprise that the ocean is no different?
Well, they're not surprised that the ocean's warming. They have understood for many years now that the overall man-made global warming that we're experiencing all over the world in all these different ways is going to affect the oceans. Water is very absorbent for heat, and a lot of the extra heat that we're producing from the burning of fossil fuels, a lot of the extra heat that's being caused in the atmosphere as a result of that is just getting sucked into the ocean. And bit by bit, over the last many decades, the oceans have gotten warmer.
So even after the air cools, say in winter or something, the ocean holds on to a portion of that heat.
That's right. Even when it's cold outside, the oceans, year after year, have been getting a little warmer as a result of climate change.
But that on its own does not account for the kind of warming that we're seeing right now.
Not even close.
So what else do they think could be going on?
Well, for the last year or so, the Pacific Ocean has been going through an El Niño cycle, which is when a lot of excess heat is released from the ocean. And in addition to making the Pacific Ocean hotter, it has sort of an overall warming nudge, a little boost for warmth in ocean heat around the world. But even that doesn't explain the big jumps we've seen. And there's another counterintuitive factor that scientists believe is playing a role here as well. And that has everything to do with the pollution being emitted by big ocean liners, by big ships traveling across the Atlantic. So in 2020, some shipping regulations changed, and they required that the emissions from the fuel being used in big ocean tankers become much cleaner. And as a result of that, there was less sulfur dioxide in the shipping emissions. That's a good thing for many reasons. Sulfur dioxide is a pollutant. It can have really adverse health effects on humans. But one of the things it was also doing was refracting sunlight away from the oceans. And so what we've seen over the last recent years is as there was less sulfur dioxide in the North Atlantic, as less and less of that particulate matter was in the atmosphere and able to bounce the sun's energy back into space, more and more of the sun's energy, more and more of the sun's heat was making its way into the oceans. And that, scientists are now understanding, likely played a warming role as well.
So basically, lower emissions in these shipping lanes means less kind of smoggy cloud cover, and therefore more direct sunlight hitting the ocean surface and heating it up, which actually kind of rings a bell because we talked about this in the show recently in relation to scientists wanting to artificially create more potent cloud cover to cool down the planet. It's a little ironic that scientists are now trying to engineer the very thing we were trying to stop doing. Talk about unintended consequences.
That's right. And this is one of those instances where there are these very tough trade-offs, right? It's great, yes, that we have less pollution. That's going to be good for public health. On the other hand, it may have allowed yet more warming in the oceans that's having cascading effects across all sorts of ecosystems that we're only just beginning to understand.
Yeah, let's talk about that for a moment. What are the effects of this mysterious warming? You mentioned ecosystems.
Well, there are a lot of effects when the oceans get this hot, this fast. But perhaps the most immediate concern among people all over the world is the fact that in dozens and dozens of countries all over the world, we're experiencing a record wave of coral bleaching, which is to say that coral reefs, these vitally important parts of the ocean ecosystems, are just dying at a rate we've never really seen before. And that's going to have all sorts of negative effects for fisheries all over the globe.
Why are coral reefs so important?
Well, they matter for a lot more than just snorkeling. Yes, they're beautiful, and yes, they are the center of a lot of tourist activity, but they're also sort of this fundamental, foundational part of the marine food chain. And so when we think about all of the life that coral reefs sustain, that all allows for smaller fish to flourish and go out into the ocean. And those smaller fish contribute to the lives and the ecosystems of bigger fish. And when we think back to, the food chain that we learned about when we were in elementary school, coral reefs are right at the bottom of that. And if we lose that, it's going to have devastating effects for marine ecosystems all over the world.
Is there any hope to save the coral at this point, or are they doomed?
My colleague Katrin Einhorn has been doing a lot of great reporting on the situation with corals, and she's highlighted some of the efforts underway to try to save them, to grow more resilient corals. But the truth is, the scale we're seeing with bleaching events happening all around the world in something like 56 countries, it's just not possible to stop it entirely at this point.
So it's one of these dominoes in our ecosystem that can set off a whole range of problems and actually result in major losses to biodiversity.
And just to come back to the mystery of it all, we just don't know what happens when those dominoes start to fall.
Mm-hmm.
And it's not just corals that are being impacted here. The weather could well change as a result of these warmer oceans as well. And I'm particularly thinking about the upcoming Atlantic hurricane season. Warm water is a key ingredient to hurricanes. When you think about hurricanes and how strong they get and how fast they intensify, one of the most important factors in both of those dynamics is how hot the water is. And when we see all this warm water hanging out in the Atlantic Ocean, that is leading forecasters to predict a potentially record-breaking hurricane season that is right around the corner in the North Atlantic. And that could affect the Caribbean, North America, and beyond.
What's striking to me is that, we know that the oceans are getting much hotter. We don't fully know why, and we can't fully explain what the impact will be, which really doesn't sound great. But if we don't fully understand what's going on, then how can we even hope to do something about it?
Well, I've been asking scientists this very question, right? Like, what is there to be done? And the tough answer is there's no easy way to turn down the thermostat of the oceans.
Mm-hmm.
This warming is happening, and our job now is to live with it as best we can. And we haven't even talked about what some people regard as the biggest threat of all. As the oceans warm, they're contributing to the melting of glaciers and the loss of Arctic sea ice. And as that happens, many people are worried not just about rising sea levels, but also about the disruption to a vitally important ocean current. And if that happens, it could have massive ramifications for the entire planet. It could change just about everything we know about life on Earth.
After the break, my colleague Raymond Zhong talks about the possibility of that ocean current collapsing. We'll be right back. Raymond, before the break, our colleague David Gelles told us all about this alarming trend of the ocean heating up and some of the very worrying consequences of that. But you are here to tell us about something else that may be happening in the ocean, something to do with ocean currents. And if I'm honest, it sounds like something straight out of a science fiction movie. Can you explain?
Sure, Katrin. And actually, you're right. It is something from a science fiction movie.
I'm here at the Global Warming Conference in New Delhi, where, if you can believe your eyes, it's snowing.
About 20 years ago, a movie called The Day After Tomorrow came out.
The only force strong enough to affect global weather is the sun.
What about the North Atlantic Current? I got a call last night from Professor Rapson at the Headland Center. He thinks the current has changed.
Oh, come on, Jack. How could that be?
And the plot of that movie is that there's this major ocean current in the Atlantic that suddenly stops moving. It collapses. And it sets off this cascade of natural disasters.
In Nova Scotia earlier today, the ocean rose by 25 feet in a matter of seconds.
What you're seeing are two actual tornadoes striking Los Angeles International Airport.
It's a mob scene here at Grand Central Station. Over half the platforms are flooded and service has been suspended on all trains.
That ultimately plunged the planet into a new ice age.
What can we do?
Save as many as you can.
I guess my question to you, Raymond, given what we're talking about here, is which part of that movie is science fiction and which part is actual science?
I'd say most of the movie is pretty purely fiction, but there is a kernel of truth in the science, which is that this vital ocean current in the Atlantic is very real. And just like in the movie, scientists are worried about what happens if it shuts down.
Okay, so tell me about this current.
Scientists have given it a very, very unwieldy name. They call it the Atlantic Meridional Overturning Circulation. But most people just use the acronym AMOC, AMOC.
AMOC, okay.
Think of it as a giant conveyor belt of water that loops around the Atlantic Ocean. And it starts near the equator, goes up through the Caribbean, around the east coast of the US, up toward northern Europe, and then back again. Scientists have come to realize how important AMOC is for a lot of the climate that we enjoy today. A lot of northern Europe, Britain, Iceland, Scandinavia, is habitable today really because of AMOC. It's because this system transports heat from the equator and very generously drops it off in northern Europe that even though it's so far from the equator, it's not as uninhabitable as, say, far northern Canada or Siberia.
And let me just ask you, is this AMOC current the same thing as the Gulf Stream, which people write about and are worried about a lot these days?
Yeah, the Gulf Stream is a similar system of currents, but AMOC is sort of the full loop. The Gulf Stream is just one part of it, but AMOC is really what's important for the climate.
Okay, so before we talk about AMOC shutting down or collapsing, can you actually kind of give me a quick Science 101 explanation of how this thing works? Like, there's this massive loop of water, like a sort of, I guess, an underwater river that you described, which kind of transports warm water up towards the north and then comes back as cold water. What keeps this thing running? How does a current just stay in constant motion and loop around like that?
It has to do primarily with differences in temperature and salinity. Basically, fluids want to keep moving in a particular direction. And it's driven by this balance between warm water, cold water, salty water, fresh water. Heavier water wants to sink, lighter water wants to rise. And so the temperature and salinity of the water is sort of what determines how dense it is. And this density and differences in density keeps this giant loop moving. It's something that explorers noted in the Atlantic hundreds of years ago. They noticed that deep water was very cold. It was unexpected. And so I think as people have started studying the oceans more and science has advanced, they've realized there's a very delicate system of differences in temperature and salinity that keeps this conveyor belt moving.
That's really fascinating. I mean, I've always known we had these currents and that they were really important, but I never really appreciated and understood what it takes to keep them going. So, okay, tell me why scientists are so worried about AMOC shutting down.
As the planet warms, there's something that might be significantly affecting this delicate balance, and that's the melting of the Greenland ice sheet. With the melting of the ice, there's this big infusion of fresh water into the northern Atlantic. And because that affects the salinity of the northern Atlantic, it sort of changes the balance of salinity and temperature, potentially enough to knock this loop off course. And there's signs already that this is happening, that at least the current is slowing down. And one major piece of evidence is this cold blob that's appeared in the northern Atlantic.
A cold blob.
A cold blob, that's right. With almost everywhere on the planet getting warmer because of the greenhouse gases that we're putting into the atmosphere, there's a conspicuous blob in the North Atlantic near Greenland that is getting cooler. And it's exactly the place that scientists would expect to be getting cooler if AMOC were slowing down.
Okay, so the Greenland ice sheet is melting due to climate change, and that seems to be disrupting this current. So as a result, less warm water is being transported north, and that's why we have this cold blob that scientists have noticed in the North Atlantic.
That's right.
And do we know what would happen if the current collapsed today?
So the best source of information we have about what happens when AMOC collapses comes from about 12,800 years ago, which is, as far as scientists know, the last major time this happened. Basically, the climate changed really, really quickly, at least by geological time. It was sort of less than 100 years, as far as scientists know. Much of the northern hemisphere got cold again. The temperature in parts of Greenland probably fell by about 18 degrees Fahrenheit. Forests were replaced by tundra. Ice sheets grew again. As far away as California and the southwestern U.S., you had evidence of cooler, drier conditions. And as far as scientists can tell, this may even have contributed to the disappearance of some of our early hunter-gatherer civilizations. Some of our ancestors were probably pushing into new territory as the ice sheets retreated and were suddenly confronted with another blast of cold.
Wow. Okay. So the last time this happened, this current shut down, the world was basically plunged into an ice age and wiped out part of humanity. Is that the scenario we're looking at today?
I think scientists are careful about not being too precise about what it would look like if it happened again. The world, after all, is still warming. And so in a lot of ways, the climate is already quite different from the one that was around at the time. But certainly, I think scientists expect Northern Europe, the UK, Iceland, Scandinavia, to become a much colder place, even than it was 200 years ago, before the Industrial Revolution, before humans started adding greenhouse gases to the atmosphere.
How cold are we talking? You mentioned the UK. I'm in the UK right now. I mean, would Britain suddenly look like the frozen tundra?
It would be significantly colder. It's far north enough to really be almost Arctic. And I think an AMOC collapse could bring much stronger winter storms, deep cold in the winter that would be extremely dangerous. But at the same time, that cold around the North Atlantic doesn't just translate straightforwardly into cold everywhere. Basically, if you don't have AMOC, you have more heat that stays around the tropics and the equator. A warm ocean around the equator gives the fuel to storms around the equator and rainfall around the equator.
So it's not just about getting that warm water from the tropics to Europe, it's also getting that warm water away from the tropics to avoid things like extreme weather events.
That's right. And it's not just about the temperatures people would experience. It's also about agriculture. And especially in vulnerable places like Africa, big shifts in rainfall, big shifts in temperature could really affect food chains, food supplies, our ability to feed ourselves.
And what does that mean for humans living in these places? Like you were saying that 13,000 years ago, Northern Europe basically wasn't inhabitable anymore. Would humans still be able to live in these places?
We, as a civilization, as a species, obviously have some ability to withstand a range of temperatures, a range of weather conditions. But we really haven't seen, in our recent history at least, changes as fast as the ones scientists imagine an AMOC collapse would bring. It's really hard to say, is Northern Europe ready for a much colder climate than it is right now? If, for instance, sea level rise accelerates on the east coast of the U.S., are cities there prepared? That's another consequence of AMOC that scientists are worried about. And it's obviously already happening. And you can see the effects of sea level rise in places like the Gulf Coast, North Carolina, Florida, even New York. But certainly it would be a test for countries, societies around the Northern Atlantic that they haven't seen before.
Okay, that's a very scary prospect with everything that goes with it. You know, mass floods and displacement of people, climate migration, everything that you can sort of imagine. When do scientists predict that this could actually happen based on the data they have and assuming, of course, current human behavior and emissions don't change?
As best as scientists can tell right now, they know AMOC is weakening. They expect it to continue weakening. Whether a collapse is imminent, whether it's far away, is still really, really hard to say. But it couldn't quickly be reversed. Once you sort of started on this process, the system just keeps moving in that direction.
Like a point of no return.
That's right.
So if we're already seeing signs that this current is weakening, does that mean we're possibly already past that point of no return? Is it no longer a matter of if, but when?
The really short answer is we just don't know. The best guess is that it's not going to shut down this century. But plenty of scientists are worried. It's something that a lot of them are focused on very intensely, just because we do think the consequences, if AMOC did shut down, could be so catastrophic.
If that current collapsed, though, like, is there anything we could do to bring it back? Like, it did come back 13,000 years ago, after that last ice age. What happened?
Short answer again, nobody is quite sure. It seems to have abruptly grown warm again over 40, 50 years, but it's pretty unclear why. And I think as far as what would happen today to bring it back, scientists would still say cutting greenhouse gas emissions and preventing the planet from overheating is probably the only thing we have in our control that could influence the climate on that scale.
I mean, it's sort of where we land at the end of every episode about climate change. And it's sort of interesting. I mean, probably like a lot of people listening to you, I find all this pretty scary and dystopian and worrying. It's kind of crazy to think, actually, that scientists have warned about this for decades. That there was even a science fiction movie made 20 years ago, which, you know, in some ways predicted what might be the real consequences of this current shutting down. It's not like we humans lack the imagination of like all the terrible things we're risking here. But when it comes to protecting ourselves and the planet against this existential threat, we are clearly unwilling to do what it takes.
Yeah. Scientists have been thinking about AMOC and had a pretty good grasp of what AMOC looked like decades ago. As early as the 80s and 90s, scientists made this connection between the warming that humans were bringing about and consequences like an AMOC collapse and other things as well. It was one of the scientists who wrote about AMOC in the 80s who said the climate system is an angry beast and we are poking it with sticks. And that's still true today.
Well, Raymond, thank you very much.
Thank you, Katrin.
We'll be right back. Here's what else you need to know today. On Monday, the judge in Donald Trump's hush money trial held the former president in contempt for repeatedly violating a gag order and threatened to jail him. The judge told Trump that the last thing he wanted to do is to put him in jail, but at the end of the day, he had a job to do and would seriously consider it. And Israel stepped up its attack on the southern city of Rafah in Gaza, hours after Hamas said it was ready to accept a ceasefire proposal. The proposal was put forward by Egyptian and Qatari mediators, but Israel responded by saying that it failed to meet its demands. The Prime Minister's office said it would still send a delegation to talk about how to reach an acceptable deal. Today's episode was produced by Carlos Prieto, Michael Simon Johnson, Alex Stern, and Diana Wynn. It was edited by Devin Taylor. Contains original music by Rowan Nemisto and Marion Lozano. Our theme music is by Jim Brunberg and Ben Landsberg of Wanderly. That's it for The Daily. I'm Katrin Benholt. See you tomorrow.